In this lesson, we are going to be working on simplifying rational expressions. A rational expression is truly a fraction, but now instead of just having number values, we will also have variables. So, if you recall, when we simplify fractions, we're simply dividing the top and the bottom by the same value. Essentially, we're dividing by 1 because 2 over 2 is 1. And that is why when you consider fractions that are of equivalent or of equal value, that they are the same, even when simplified. So for example, we've always talked about if you had 2/4 of a pizza and your friend had a half of a pizza, you have the same exact amount of pizza. It's just that your pizza was divided into more pieces, but you're getting the same amount. When we are dealing with fractions where we have an operation on the top, we can simply add and then we can simplify. We also could simplify first as long as you simplify both the top and the bottom by the same exact amount. And then we could add them together and we'll get the same answer. But you have to divide by both by the same amount. So when we have variables, we simply do the same thing. In this case, we're going to divide both the top and the bottom by 6. And we'll get x over 2 as our simplified fraction. On this one, we're going to divide both the top and the bottom by 6, but we're also going to divide the top and the bottom by the same amount of variable, which would be an x squared. So when we divide the top and the bottom by 6x squared, we would get 5 over 3x as our simplified fraction. Now, when we are going to simplify fractions that have expressions in them, if you cannot divide the x into both quantities, then we can't do it at all. So the best way for me to describe this is a quantity. I'm going to put parentheses around it has been factored. And if x can't divide into the whole entire quantity, then it is simplified. I've told students in the past that I consider the parentheses to be a firewall and you cannot go inside because you will get burnt. So 2x minus 3 is simplified, and so is x minus 3. And so since the quantities are not the same, we can't divide them, we can't simplify. Now here's an example where I'm going to divide the top or factor the top by 2. And I get 2 times the quantity x minus 3. And the bottom I have x minus 3. Now in this case, since the quantities are exactly the same, we can divide x minus 3 divided by x minus 3, and our final answer will be 2. So the big thing to remember is always to factor first. And then we can simplify factors. So in the next example, we have x squared minus 4, which can be factored to x minus 2 and x plus 2. And on the bottom, we have the factor x minus 2. Since those quantities are exactly the same, we can simplify those, and our final answer will be x plus 2. In the next example, we will factor first. So on the top, we could use our x if you're comfortable with that. What two numbers multiply to be 6 but add up to be 5 would be 2 and 3. So this would be x plus 2 and x plus 3. The bottom we have the difference of squares, which would be x plus 3 and x minus 3. We can simplify if they are the exact same factors. So our final answer will be x plus 2 over x minus 3. I ask that you leave the parentheses just as a helpful reminder to you that we can't simplify any further. In the next example, in the numerator, we could divide both the terms by 6, and in the bottom we have 2x. So we can simplify. 2 goes into 2 once, and then 2 goes into 6 3 times. Sorry, having problems with my pen. But the x doesn't simplify at all. So we have left 3 times x minus 3 over x. And that is our final answer. Now in the next example, what I would do is I would rewrite the denominator to be negative x squared plus 25. Now it looks very close to being the difference of squares. So I'm going to rewrite my numerator, and I'm going to divide both terms by negative 1 so that now it is the difference of squares, so we'll be able to factor. So on the top, if we make our x, what two numbers multiplied to be 10 but add up to be 7 would be 2 and 5. So we have x plus 2 and x plus 5. And on the bottom we have a negative 1, and then we have our difference of squares, which is x plus 5 and x minus 5. So we can simplify the x plus 5's. And what we would have left on the numerator would be x plus 2. And in the denominator, we'd have a negative 1 and x minus 5. And that would be our final answer. Your job is to finish the next 6 problems to show that you factor first and then simplify.